Let's solve another problem, which is 12-124 of your RC Hibbler. And in this problem, you can see that you have a box of negligible size and it is moving along this curve path. Okay, and this curve path is actually parabola whose function is given to you, and it is also provided that when it is at point A, its position is uh, 2 and 1.6 from this origin, right? And its speed is given, which is 8 meter per second, and the acceleration is also given, which is 4 meter per second square. You have to determine the magnitude of the acceleration of the box when it is at point A. So now this is actually a curvilinear problem, and we are going to solve it by using normal and tangential coordinate system. And from the data you can easily imagine that the as it is moving in a curved path, then its acceleration will have two components. One is along the normal axis and the other one is along the tangential axis. So this is the tangential acceleration, which is actually at is 4 meter per second square, right? Velocity is also given, so you have to calculate the resultant acceleration, and the resultant acceleration is a is equals to at square plus an square, right? So at is provided to you, you have to calculate this an. How you will calculate this an is equals to v square by rho. So over here v is also provided to you. You have to calculate this radius of curvature at point O. So how you can calculate it? We have studied it earlier that if the function is given to us, then we can easily calculate the radius at that point by using the relation, which is uh, rho is equals to 1 plus dy by dx square 1 by 2 divided by d square y by dx square, right? So you can use this relation and find the radius of curvature. When you will put this value over here, you can easily find the normal acceleration, and after that you will get the resultant. So please differentiate this function, and uh, you can easily calculate the radius of curvature. So do it by yourself and solve the given problem. Okay, we have studied normal and tangential coordinate system. Now we are going to study the cylindrical coordinate system, that if our particle is moving in a curved path, then its motion can also be represented in a cylindrical coordinate system. So in contrast to the rectangular coordinate system, as we have three axes x, y and z coordinates, so in this cylindrical coordinate we have the radial axis or radial direction, we have transverse axis which is theta direction, and we have the z axis. So we can represent the position, velocity and acceleration in terms of these coordinate systems to analyze the motion of our curvilinear motion. So as we have studied that in the rectangular coordinate system, the position can be or the velocity can be represented in x, y, z. Like for suppose we can represent our velocity in terms of vxi plus vy j plus vzk. That is how we can also represent, where I is the unit vector and Vx is the magnitude. Similarly, we can represent the position and velocity in terms of cylindrical coordinate system. So for suppose the unit vector represented the transverse direction, radial direction and z direction represented by uz, u theta and ur. So we can represent our velocity with the relation like uh, for suppose we can represent our velocity as v is equals to vr ur plus v theta u theta plus bz uz, right? So u r u theta and uz are the unit vectors, whereas the vr v theta and vz are the magnitude. So these magnitude can be calculated by using the relation as vr is equals to r dot and v theta is equals to r dot r theta dot, and similarly vz is equals to z dot. We are not going in the details of the derivation of these relation, rather we are using the results only. Similarly, we can calculate the acceleration, which is a is equals to arur plus a theta u theta plus az and uz. Similarly, the magnitude can be calculated by using the relation uh, AR is equals to R double dot minus R theta dot square, right? Where A theta is equals to R theta double dot plus 2R theta theta dot, and AZ is equals to Z double dot, right? So you know it very well what R dot means. So R dot is actually is dr by dt, right? We talk about z dot, so it's mean dz by dt, right? And double derivative is represented by the double dot. So these are the relations which we can use to find out the position, velocity and acceleration of the particle moving in a curved path by cylindrical coordinate system. I want to remind you that the selection of the coordinate system is based on the available data and the problem which is given to us. So we will decide it that which coordinate system will be helpful to analyze our problem, and then we solve it accordingly. So if you want to see the derivation of these equation, you can refer to the book, but we are only using these results and will apply it in solving the numerical. So let's move ahead and solve some problem related to cylindrical coordinate system. Okay, let's solve a problem related to cylindrical coordinate system. So here this is a problem F12-34, and in this problem you can see that this is the platform in which there is a slot in which there is a ball, right? And for suppose when this platform rotate, what will happen, the ball rolls out from that disc or platform. So at any instant we are provided with the transfers, its transverse position or theta, which is 43 by 2, and we have to we are also provided with the position of the ball, which is r.1 t cube. We have to find the magnitude of the velocity and acceleration after 1.5 seconds. So of course, for suppose is when the ball is over here and this start to move, then due to this it will have some force which tends to move it outside the platform. So after some time it will move in the transverse as well as radial direction, right? So this is actually a problem in which there is you do not have any z-axis, right? So you will calculate your or you will have the velocity and acceleration component in terms of only transverse and radial direction, where z direction will be eliminated because this is a 2D problem. So, as far as the problem related to cylindrical coordinate are concerned, we will first try to find out the r dot and r double dot. Similarly, we will try to find out theta, theta dot, theta double dot, and finally z, z dot, z double dot. So this is the procedure. First we will calculate these variables, and after that you will know that the velocity and the acceleration uh, have the relation with these three variables. So we will put values and will solve the given problem. So let's calculate the r dot, r double dot, then finally theta, theta dot, and theta double dot, where all these z values will be eliminated because the problem is a 2D problem. So let's solve the problem. So you can see that we are provided with this r and this theta. So we will calculate this r dot and r double dot. How? You know that r dot is actually the dr by dt, right? So when you differentiate it with respect to time, you will get 0.3 t square, and after that you will have 0.6 t. Similarly, theta is provided to you, which is 4 3 by 2, and theta dot is actually uh, d theta by dt. So you will get 6t by half, and this theta double dot. So the time is given to us, which is 1.5 second. We will put values in these relations and will apply into the equation of the velocity. So I have told you that velocity can be represented in terms of v is equals to this vr ur plus v theta u theta and plus vz uz. So the z component is 0 over here, so we will only uh, deal with these two components. So this is the unit vector where this is the magnitude, and vr can be calculated as theta dot, and v theta can be calculated as r theta dot. You have the values over here which you have calculated earlier. So you put value and you will have this velocity vector in terms of ur and u theta. So in order to calculate the magnitude, you can calculate it by having the Pythagoras equation, which is v is equals to vr square plus v theta square, right? So when you calculate it and solve it, you will get 2.57 meter per second square. Similarly, uh, we are uh, we will also calculate the acceleration, and we will adopt the similar procedure as we have calculated the velocity, right? So let's move ahead and solve for the acceleration. Now this is the solution for the acceleration. As we have studied that in cylindrical coordinate system we have acceleration and its three component, which is a r u r plus a theta u theta plus a z u z, right? So we will individually calculate the magnitude of these different components. So this AR will be equals to R double dot minus R theta dot square, and this A theta is R theta double dot plus 2 R dot theta dot. So this is the relation for this A theta and AR. As this is a 2D problem, this component will be 0. So we have calculated this r double dot or theta, theta double dot. So we will put values in these equations, and after that we will calculate the magnitude by using the Pythagoras equation, right? So this is the concept quiz. If you have completely understand the concept, then please try it and solve it by yourself. Okay, let's solve another problem, which is problem 12-192. And in this problem you can see that we have a arm, we have a robotic arm in uh, which is actually extending in the radial direction, and moving, also moving in radial, transverse and the z direction. So over here the position of this arm can be represented in cylindrical coordinate system by theta, r and z coordinates, and the data which is given to us is r dot, r, z and theta, and we have to calculate the velocity and acceleration of the grip A when t is equals to 3 seconds, right? So after 3 seconds we have to calculate the velocity and acceleration of the grip. So I have told you that for solving such problem, first we need to calculate the r, r dot and r double dot, right? Then we will calculate the theta, theta dot, theta double dot, and then we calculate z, z dot and z double dot, right? So over here r is given to us, which is 3 feet, right? What is the r dot, which is also provided to us, which is 1.5 feet per second. Similarly r double dot, which is d theta by dt, d r dot by dt is 0, right? Feet per second square. Similarly theta is zero point 0.5 t radians, right? So theta dot will be 0 0.5 radians per second, and theta double dot will also be 0 because theta dot is a constant. So radians per second square. Similarly z is actually 4t square, which is in feet. So theta double dot will be 80 feet per second, and z double dot will be 8 feet per second square. So these are the basic initial variables which we need to calculate. Now we will find out the velocity and acceleration at t is equals to 3 seconds. Now for the velocity, we know that v is equals to vr ur plus v theta u theta plus vz uz, right? So over here this vr is actually r dot, so it will be r dot, we have 1.5, right? And this v theta we have r theta dot, so this r theta dot is r, which is r is r is 3 feet, right? So this is 3, theta dot is 1.5, so you will get 4.5. Similarly vz will be z dot, so z dot is 24 feet. Feet per second is 24, right? So we will put in this equation, which is equation 1, and we will have that v is equals to 1.5 ur plus 4.5 u theta plus 24 uz, right? This is your vector, and you can calculate the magnitude by taking square of these magnitude. So this is 1.5 square plus 4.5 square plus 24 square, and after solving you will get 24.5 feet per second square. Sorry. So that is how you can calculate the velocity of the robotic arm after the 3 seconds. So similarly you will adopt the same procedure for finding out the acceleration of the robotic arm. Now we can calculate the acceleration of the robotic arm by this equation. We know that A is equals to ARUR plus A theta U theta plus AZ UZ, right? So we know that this AR is actually R double dot minus R theta dot square, right? And we have this A theta is equals to R theta double dot plus 2R dot theta dot, right? And we have this AZ is equals to Z double dot. So we can put the values in these relation. So uh, this R double dot we will have 0 minus R will be 3 and theta double dot which is 1.5 square, right? And when you will solve it you will get 6.75. Okay, now you have R which is 3, theta double dot 0 minus plus 2 R dot which is 1.5, theta dot was also 1.5. So when you solve it you will get 4.5, right? And this will be the 8. So when you put value in this equation you will get the vector acceleration, and you can calculate the magnitude by 6.75 UR plus 4.5 U theta and plus 8 UZ, and A will be calculated as 6.75 square plus 4.5 square plus 8 square, and you will get 11.4 feet per second square, right? So that is how we can calculate the acceleration of the robotic arm. So this is the procedure by which we can solve curvilinear problem by using the cylindrical coordinate system. So any curvilinear motion can be defined in terms of the rectangular, normal and tangential and cylindrical coordinate system based on the available data and the given scenarios. So here we are ending this curvilinear motion, and we will start the other topic, which is the dependent motion analysis. Uh, Please read the respected topic in your book and try to solve this attention quiz, and you can discuss this in the live class.